So in this video, we're going to talk about the big O of functions with multiple inputs. So far, we've only talked about functions that takes a single input, right? Usually just one list, even though the list has multiple items of different sizes, but it's one input. Now, what about, obviously, there are functions with multiple inputs, right? So what about the big O for functions with multiple inputs? So let's look at an example, and I do believe it's probably straightforward, I hope. So think about this for a moment. For this function, it just takes two lists, L1 and L2, and it just goes through L1, print every item out, L2, print every item print every item of L2 out. So let's say the size of L1 is n and the size of L2 is m. What would be the big O of this function? Well, so we know that for the first loop, for the size of L1, that is size of n, it's going to be O of n, right? Linear in terms of the size of L1, right? And then for the second loop, it will be O of m, in linear to the size of L2. And because one loop just happens after another, so the O for the entire function is just we add these two together. So the big O is O of n plus m. Okay. Next kind of exercise. So what about a matrix? Then let's say this matrix has n rows and m columns, right? And the matrix is stored as a list of lists, as we've seen before. So what is the big O of this function that just goes through the rows, and then for each row it prints out each of the cells in the row? Okay, so the answer is, I hope you've seen this, that if you just look at the inner loop first, right? The inner loop goes through everything in the row, and the size of the row is the number of columns. So basically that's m. So the inner loop is O of m. Now the inner loop is repeated for all the rows, and there are n rows. So we'll do the inner loop O of m n times. So then together they are the big O for this function would then be O of n times m. Okay, so this is how we go about reasoning about the big O of functions with multiple inputs.